Adam Hammond, welcome to Inside GITEX podcast. Delighted to have you.
Delighted to be here.
You have a very impressive resume. You've worked 32 years at IBM and you're the business leader for IBM Quantum. Is that right?
Yeah, for Europe, Middle East and Africa.
That is very, very impressive.
Thank you.
To stay at a company for 32 years and as a starting point, it's very, very impressive. What's made you stay there for so long?
I think there's always something new to do. I haven't done the same job for 32 years. I've done all sorts of jobs.
Yeah.
I've lived around the world. I've just, there's always been a new opportunity, and I've always liked to work at the cutting edge of technology, and I find myself again at the cutting edge of technology.
Yeah,
it's
you're
exciting.
in a great place.
Yeah.
You're in a great place. You're based in the UK.
I'm based in the UK.
And you've flown over especially just for GITEX?
I've flown over for GITEX and also to meet sort of clients in this region.
Okay, you've been to GITEX before, or is this your first time?
This is my first time to GITEX in Dubai. I went to GITEX in Berlin earlier this year.
Okay, how was it?
It was very interesting. It was obviously the first time that GITEX has run in Europe.
Yes.
So I think a lot of people were feeling their way, but I think it has a long and bright future.
Very nice. First impressions of GITEX here in Dubai?
My first impressions was getting on the metro this morning.
Busy.
It's busy.
That's very diplomatically
it's
put.
busy.
I love that.
It's huge, but everyone's here.
Everyone is here, especially on the first day. The first day, second day. I mean, all days are important, but typically the first 2 days, it's very busy. So I want to ask you some very simplified questions, if that's okay with you, because you're a very smart man. You work in quantum computing for IBM. It means that I'm already out of my depth, but I'm going to do my very, very best to keep pace with you. But the first question is, when you try to explain what quantum computing is to your friends at dinner, how do you go about doing it?
I think you start off by saying that it's very tempting to think with in this era of supercomputers and these that everything is a solved problem. And the reality is there are whole classes of problems that today's computers are pretty bad at, actually not even approachable. And some of these problems are really important to us. Give
me an example.
How about simulating the way that a drug works so that you can test it in software before you actually go out and do clinical trials with it? Or creating new materials. I mean, I think we're all very conscious of the limitations of today's electric vehicle batteries. So how do you actually create new materials that will allow us to have better electric vehicle batteries and address things like climate change?
Yeah.
And you want to be able to do that in software before you actually go out and build these things using chemicals. And quantum computing allows, because of the way it approaches doing computing, it uses these quantum mechanical effects that we've known about for 100 years or more, but it actually uses them to solve certain types of maths that classical computers are really not very good at.
Yeah.
And it's these types of maths that helps us solve these kinds of problems that classical computers can't do. In financial services, how do you get optimize investment portfolios better?
Yeah.
So we're making compromises all of the time in the way that we try and solve these problems, and maybe quantum computers will mean that we have to make fewer compromises.
How good were you at maths at school?
How good was I at maths at school? I was pretty good at maths at school. That was quite a long time ago. So. And sadly, I realise my maths now is not nearly as good as it used to be.
Well, it doesn't need to be. I mean, that's the key as well, potentially. So what's the one sort of biggest misconception or myth around quantum computing? What do people always get wrong that really annoys you?
Nothing annoys me because I think this is a new technology, but I think the one misconception is that it's a bigger, faster supercomputer that's going to do everything that we can do today faster, or that it's going to replace today's classical computers, because those things are not true. It's not going to make everything that we do today on classical computers faster. Okay. In fact, actually, to start with, it's probably only going to do very little bits.
So what would be possible, let's say, in the next decade? If it all goes to plan, everything works,
what's going to be
what is the possibility? What can happen?
I think we'll start to see pharmaceutical companies designing drugs in software so that they can test them, so that when they go out to clinical trial, they will have proved in software that they should work. And so it's the final thing. So rather than testing 10, 20, 30 compounds, they'll just test the one or two that look as if that's a dramatic saving in cost, also bringing drugs to market. I think you'll see energy companies using quantum computers to better balance generating sources, being able to choose more climate-friendly generating sources in better ways. I think you'll see new materials coming.
What about in the financial markets? Will we be able to see real predictive understanding through quantum computing to really change how things are traded and sort of how to...
So we have a really good example of that. So 2 weeks ago, we published a paper with HSBC. And we've been working with them for a number of years. And for this particular experiment, so we're working with their algorithmic trading team. So they basically trade using formula, using machine learning models. And this experiment was to see whether we could make an improvement in the efficiency of their trading by sprinkling a little bit of quantum fairy dust on it. So we helped them build their machine learning model.
That's a multi-trillion-dollar product right now.
So one of the challenges they have with algorithmic trading is they have to get the balance between, the price they're willing to pay and the price that they can sell at right, so that their clients are willing to buy, the people they're purchasing for sell, and as a result of getting it wrong, they lose a lot of these trades. And we were able to demonstrate that with the addition of a little bit of quantum on this sort of sample data, so this wasn't production, 34% improvement in orders fulfilled, which translates to millions. So I think the answer is we think financial services may well be one of the very early beneficiaries, because very, very small improvements could result in millions of dollars,
billions and trillions, Adam. Let's be honest.
Absolutely.
And we're talking not just in the traditional markets, right? We're talking also in the crypto markets. We're talking in digital asset market.
I think anything to do with optimization, if it's portfolio optimization, if it's risk management, anything in this optimization space, there's a real opportunity just being able to make small improvements that will deliver huge returns.
So what are you working on right now? What is the biggest problem that I'm just imagining you guys all getting together, guys and girls, super smart people in a lab somewhere, cooking up stuff. What is the one problem that you're trying to solve right now? What are you working on?
So I think the hardware for quantum computing has really come on in leaps and bounds over the last couple of years. We now have machines that are really usable to do research, not yet production, but definitely to do research into problems. What we are challenged with, though, is the algorithms, it's the software, it's the applications, because really we've only had machines at any scale in the last sort of 2 years. So the biggest focus for us is reaching quantum advantage, which is where we can demonstrate that there are real use cases where a quantum computer can really go beyond what a classical computer can do, which is sort of the nirvana as far as we're concerned. It's the reason for being for quantum computers.
Is there a worry that you might have inside about how far you can push what a computer can actually do?
No, I don't think so. I think we're already quite confident that this is a technology with a future, and that it's going to achieve what we set out for it. The timings, are still a little bit unclear. We stood up actually this summer and said that we expect to see some kind of quantum advantage in some kind of space next year.
Wow.
We announced a roadmap to fault-tolerant quantum computing. So
What does that mean?
So today's machines are very noisy, they're error-prone, and that limits the amount of work you can do with them. So basically, it limits the size of the problem that you can deal with. And that's one of the reasons why it's quite tough to put them into production today, because the problems typically you need to solve in production are larger than we can do on these machines. But to give you some idea, and this is a fairly arbitrary measure, but we measure our current machines and the operations you can do per circuit, per program. So today it's 5,000. We go up to 7,500, 10,000, 15,000. In 2029, we jump to 100 million. In 2033, we jump to 1 billion. And that, if you think about that as the problem size, we see an explosion in what you can do.
So it's 5,000 today.
It's 5,000 today.
What was it 5 years ago?
Nothing, almost. It was small enough that you could do it on your own. You could simulate it on your own PC, on your own laptop. So we didn't really count it that way. Now we've got to the stage where there are things that you can do on a quantum computer that you can't simulate on a laptop. So now, now we start to measure the size of the problem that way.
What about when the quantum computing matches with the sentience of AI and they kind of funnel together? Is that the beginning of the end for all of us?
So it's interesting. It's one of the questions I get a lot around the impact of quantum on AI.
But sentience, I'm talking about typically about understanding emotion, thinking for yourself, thinking freely, because those are sort of the two superpowers. When combined, all of a sudden.
So I think the way I would think about quantum is it gives you another set of tools to your toolbox. It's not going to suddenly magically create sentience. It gives you a set of tools to solve maths effectively. And all machine learning tools, all AI tools are all about solving mathematical problems. So yes, it'll help you solve problems more efficiently, or maybe problems that we can't solve today, but it's not going to be that sentient leap. I don't even know whether that sentient leap is even possible. What it will allow you to do, I think, is to do things that are more useful and give you more value back.
But the idea being you have more free time as an individual as well. In theory, if the machines are doing all the heavy lifting, does that not mean we have more time to focus on what makes us human and the creative instincts that we have? Or do you see it in a different light?
It's a philosophical question, isn't it? I don't know. Do people who have more time on their hands because machines have helped them do something, do they go on and do more spare time, or do they go on and use their time doing more difficult, more difficult things? I think what is very clear is that AI in business is releasing resource to go out and do more business development, to create new ideas, to address new opportunity. And I don't think quantum might accelerate that, but I don't think it's going to fundamentally change that.
Did you ever have like one of those sort of wow eureka moments where you and your team have been working together and just come up with something that's just, you saw the potential of what quantum could bring to the table?
I think...
Or was it only in the movies we see that?
No, I think one of the things that's really interesting is I work in IBM research, and most of my colleagues are scientists, researchers. And I come from a business background. And I think what's been really fascinating over the last 3 years, and more so over the last 6 months, is to see quantum move from the realm of the scientist, from being science fiction to being science fact. And suddenly, and the HSBC paper is a really good example of that, suddenly we've moved from scientific experiments to going, wow, this thing could actually make a real difference to our day-to-day lives.
Speaking of difference, what industry, if you're going to put money on it, okay, maybe not the UAE, we don't do a lot of betting here, but let's say in the UK, if you're going to put money on it, which industry will be most impacted by quantum computing? Who's going to feel it first?
Who's going to feel it first? I think financial services are definitely going to feel it first. I think the life sciences, pharma, biotech, because I think simulating sort of chemistry Materials is going to be one of the early use cases. So I think you'll start to see, maybe not full drug development cycles, but you'll start to see some of the bottlenecks in the development of new drugs, the development of new materials be addressed. So, probably not dramatic changes, but changes enough to sort of, if you can reduce the life cycle of a drug development from 10 years to 8 years to 7 years, then that's going to start to make a real difference to people's lives.
Here's a challenge for you. In one sentence, how could you make someone start caring about what's happening in this space and in tech, and make them really start paying attention to what's going on?
It's quite difficult to do that without sounding science fiction. I think quantum computing and associated quantum technologies give us the prospect of looking at our world differently, of understanding things about our world that we really don't understand before. And more importantly, will give us the ability to harness that understanding to enable us to do things that we really couldn't imagine, like, completely simulating new drugs, creating new materials where they didn't exist before. Things that sound very science fiction.
Yeah.
And this is within grasp. And we're moving into an era of new discovery.
What science fiction, you mentioned science fiction a couple of times, what science fiction movie, series, book is out there that sort of closest resembles where you see the future?
Oh dear, that's now a question. I don't know that I'm up enough on science fiction to be able to do that. I think some of the short stories that were written sort of in the 70s and 80s about new ways of doing things, new materials. I hesitate to name any because I'm quite out of date with them. But actually, even some of the things you see in Star Trek, some of these devices.
Star Trek is brilliant.
That being able to scan. I mean, it's interesting. I'm working. We're working with companies doing quantum sensing, and quantum sensing is a whole different series of technology. But actually, moving from having to put a person inside an MRI scanner to do a brain scan to just putting a helmet on their head and it reading what's going on in their brain. Well, that's actually a prototype device available today. It's things that you think of as science fiction that are really becoming.
So Adam, obviously you've got a lot of experience. You worked at IBM 32 years plus inshallah, future will be many more. What is that one insight that really rings true to you, something that you've learned, amassed over that experience? What do people need to be aware of?
So for me, it's about curiosity. It's constantly being curious about what's coming. I've been lucky enough to work on emerging technology all of my career and jump from sort of new trend, new technology. And I do that because I'm always curious about what's next. And moving into quantum was a really great opportunity. I had no experience in quantum before that, but I wanted to know what it was all about. And being able to, and I love explaining these things to, to particularly people who are not in the know. So, when people come and sort of ask me, what's the one quality people, it's all about curiosity. It's about,
I love that. It's a great insight. Do you, does this like sometimes frustrate you when someone asks you these types of questions and you think you just know so much more than they do? Does it ever sort of get to a point where you're like, man, you need to, or woman, you need to really understand this because this is going to impact your life? I
didn't start off by understanding more than anyone else.
Yeah.
I learned what I don't have a PhD in quantum physics. I don't have a physics background at all. Before I started this job, I really didn't know an awful lot about quantum computing. I knew a lot about classical computing.
So there's hope for all of us.
Absolutely.
Amazing.
And actually, I spend all of my days talking to businesses who are asking all of these questions, because you go and talk to the board of a FTSE 100 client, a customer, they don't know about this stuff. Yeah. And what I love is being able to bring them a little taste of what technology can do to transform their businesses.
Love
And so I never tire of explaining this and sort of talk about it in this way.
That's amazing. And you've got a great nature about you as well and how you explain it. So thank you for
you.
that. So final questions about GiantX. You're here. What are your expectations over the next few days?
It's all about talking to people. It's all about connecting with people. I think by 9 o'clock this morning, I'd already had 2 or 3 really good conversations that I'm going to follow up. It's a coming together of the industry with the people who want to use the technology and apply it, to their everyday lives. So it's sometimes a bit difficult to sort of work out what's what with the number of people and the number of people exhibiting, but it's a coming together of people.
Fantastic. Adam, thank you so much for joining us.
It's a pleasure.
Inside GiantX. Wish you all the very best in the future. Enjoy Dubai, and give my best to the UK when you're there.
Thank you very much.
All right.
Thanks.